Hey there! So, we're all constantly hearing about AI, right? It feels a little bit like magic. But today, we're going to pull back the curtain. We're going to forget the hype for a minute and get into the real story. The actual people and the processes that take an AI model from being just an idea all the way to that app on your phone.
So what does it really take? It's a great question, isn't it? And the answer is, well, it's not some lone genius in a hoodie coding away in a dark room. Not at all. It's more like a super complex, high-tech assembly line with a bunch of different experts all playing a critical part. So let's dive in and meet the very first person in that line.
Okay, first up, the foundation, data engineering. You have to understand everything, and I mean everything, in AI begins with data. And the folks who wrangle all that data, those are your data engineers. Seriously, think of them as the architects and the civil engineers of the entire data universe. They are building the foundation that everything else will rest on.
And the key phrase here is at scale. That is so important. We're not talking about some little Excel spreadsheet. No way. We're talking about organizations dealing with just staggering, almost unimaginable amounts of information. Data engineering is what brings order to all of that potential chaos.
So what does a data engineer actually do all day? Well, they're building what we call data pipelines. Honestly, the best way to think about it is plumbing. They're building all the pipes that take raw, messy, unstructured data from all over the place, and they transform it into something clean, reliable, and actually usable. It's their job to make sure the right data gets to the right place, safely and on time. Bottom line, without them, the AI has literally nothing to learn from. It's a non-starter.
All right, so the foundation is built, the data's clean, and it's flowing through the pipes. Now what? Who comes in to actually find the gold in all that data? Well, that's where the data scientist comes in. They're the ones looking for the hidden stories, the patterns, the real value.
And what makes them so unique is their skill set. You're looking at someone who's part programmer, part statistician, and part business expert, all rolled into one. They use that crazy mix of skills to figure out what questions to even ask, and then they dig into the data to find answers that a business can actually use to make decisions.
I love this analogy. Think of them as data detectives. For real, their process is just like solving a case. First, they gather all the clues. That's the raw data. Then, they have to clean up the evidence, make sure it's all legit and reliable. After that, they analyze everything to find those crucial hidden patterns. And finally, they present their findings to crack the case, which, in this world, is usually solving a tough business problem.
Okay, team, we've got our clean data, and our data scientist has built a model that's found some incredible insights. But that model is just sitting on a computer somewhere. How does it get into an app that you can actually use? That is where the AI engineer steps in. These are the folks who build the bridge from the lab to the real world.
The key word for them is application. They're not always trying to invent some brand new revolutionary AI from thin air. More often, they're taking these incredibly powerful pre-trained models that already exist, and they're expertly weaving them into software to build cool new features or just make the whole user experience way better.
And this brings up a really common point of confusion. What's the difference between an AI engineer and a machine learning or ML engineer? It's a great question. Think of it this way. An ML engineer is often deep in the weeds, trying to create a totally new model or algorithm from scratch. It's much more research-focused. The AI engineer, on the other hand, is more like a master builder. They take these powerful, pre-made parts, the models, and use them to construct something awesome for you and me, the end users.
So, we've got all these different experts. Data engineers building pipes, data scientists running experiments, AI engineers trying to push things live. How on earth does this whole thing work together without turning into complete chaos, right? That is the million-dollar question.
And the answer is a discipline called MLOps. You can think of MLOps as the engine room of the whole operation. It's the secret sauce, the set of rules and practices that makes the entire process automated, repeatable, and most importantly, reliable. It's like the central nervous system that connects all these different teams. It provides the automated workflows for testing, integrating, releasing, and monitoring AI models, making sure everything runs smoothly from start to finish.
Now, if you've been around software development, this might be ringing a bell. It sounds a lot like DevOps, right? And you'd be absolutely correct. MLOps basically takes the brilliant ideas from DevOps, automation, continuous delivery, but it adapts them for the wild world of machine learning. Because here, you're not just dealing with code, you're also wrangling data and models, which is a whole other beast.
And the payoff for doing all this? It's huge. You get 3 core benefits. First, efficiency. Teams can get models out the door way faster. Second, scalability. This is the big one. It means a company can manage hundreds, even thousands of models, not just 1 or 2. And third, risk reduction. By making sure every single model is tested, monitored, and governed properly, you avoid a lot of potential disasters.
But of course, right when we think we have a handle on things, the entire game changes. Enter large language models, or LLMs. We're talking about the massive AI that powers things like ChatGPT. And these things, they brought a whole new set of challenges to the table.
And to deal with that, we've seen the rise of a brand new specialty, LLMOps. It's basically the next evolution of MLOps, custom-built to handle the absolutely unique demands of these gigantic, power-hungry models.
And this table does a great job of showing just how different things are. With traditional MLOps, you might train a model from scratch. With LLOps, no way. You're usually fine-tuning a massive, pre-existing foundation model. The resources are different too. You need specialized hardware like GPUs, and tons of them. And check out the feedback part. It's not just about automated metrics anymore. LLOps introduces this critical need for human feedback. You've probably heard of RLHF, reinforcement learning from human feedback. That's where real people are rating the AI's answers to make them better. Even how we measure success is different. We've moved beyond simple accuracy to using complex scores like Blue and Rouge to figure out if the text the AI generates is actually any good.
So, when you boil it all down, what's the most important thing to remember? It's this: building real-world production AI is a team sport. It is not a solo act. It's a highly collaborative system. You've got the data engineer laying the groundwork, the AI engineer building the final product, and everyone working together inside these sophisticated MLOps or LMOps frameworks. Every single role is crucial.
And that really leaves us with a big question for the future, doesn't it? I mean, think about it. We just watched this whole field evolve from MLOps to LLOps in what feels like the blink of an eye. So as these AI models get even more powerful, even more complex, how are these jobs going to have to change? What new roles will we need? And what kind of systems will we have to invent to manage the next wave of AI? One thing's for sure, this high-tech assembly line is only going to get more interesting.